I guess you could say the results are really the only thing that matters. In our opinions, the process is just as important.
We had many problems. First was radiation. When creating a permanent human colony on Mars, several problems needed to be addressed. At the forefront of these problems was radiation. How are we protecting the astronauts from the radiation entering Mars' atmosphere? This occurred because Mars' atmosphere is very different from Earth. Gravity is much lower, as well as the density. The density in Earth's atmosphere that blocks most of the radiation is incomparable to the one on Mars. So we set out to look for a material that would effectively block this radiation. We initially contemplated conventional materials such as lead. Lead is very commonly used to block radiation because it's high dense and it is widely available throughout the world. We decided against it because in addition to the high density, it had an extreme amount of weight associated with it, and it would cause a huge amount of secondary radiation. We also considered aluminum, which has been used to coat the space shuttles by NASA. However, we were unsatisfied with just aluminum. Through further research, we looked into a material known as a polyethylene. More specifically, a material known as RFX1. We found out that it is very light, 2.6 times lighter than aluminum, yet 3 times stronger. In addition, further research showed that it was 50% better at solar radiation. Still, this material has its weaknesses. For example, it is highly flammable and intolerant of high temperatures. So we looked towards using our environment to our advantage. We decided that to protect against, for example, events such as sandstorms, as well as provide insulation, that we can again coat the habitat in the Mars soil. This would provide the ultimate barrier against temperature, against radiation, as well as block events such as a sandstorm. Now, even in light of these weaknesses, we have to remember that this material is being continually developed. This research can end these weaknesses. The possibilities with this material are endless. RFX1 should be the material of choice because it is light, it is cheap, it is widely available, it is viable, it has been researched, it has been tested, it is strong, blocks both secondary and primary radiation. Therefore, the choice was made that RFX1 and its future developments will be the material of choice for blocking radiation.
The next problem. It's the problem of food.
We knew right away that we wanted to use plants as a source of food. This is because plants would be perfect in providing both food and oxygen for our astronauts, thus killing 2 birds with 1 stone. First, we wanted to find plants which could grow in the low-pressure environment on Mars. The idea was then to use gene splicing to remove this advantageous gene and place it into an edible plant. We had many arguments regarding this, but soon we realized that this process was not cost-efficient and would thus be very expensive. This problem could be solved in a much easier fashion using a relatively direct application of the ideal gas law. The ideal gas law states a direct correlation between the pressure and the temperature of an environment. Thus, by increasing the pressure of our environment, we will also be increasing the temperature. So, we then found a plant that can grow on the environment on Mars. A study indicated that the pH of the Martian soil was between 8 and 9, thus making it perfect for asparagus, which prefers an alkaline environment. We have thus decided to use asparagus as our plant of choice to provide both food and oxygen.
Our last main problem was the problem of water. We knew water was something that would be very important. We knew we needed more than one source of water to rely on. Our first idea was to get rovers to bring ice from the polar ice caps. After doing research on this idea, we realized that most of the polar ice caps were made of carbon dioxide or dry ice. This made us decide that it would be a waste of money to build rovers that can drill ice just to get those small amounts of water from the polar ice caps. We then realized that it would be useful if we could recycle urine. We did research and found out that this was possible. Still, we weren't satisfied. Water was something that we needed for multiple uses. We wanted as many ways of getting water as possible. We continued researching ways to obtain water. We found out that water can be condensed from the humidity in the air. We realized that Mars can often be highly humid during the day and decided this would be a good source of water. We even found out that it was possible to condense our breaths for even more extra water, as it was important to obtain all the water we could possibly get.
Go. How was that?